All right, guys. So for this example that we did in class, it is 4 plus 3i over 1 plus 2i. So it's literally the exact same example again. So just a reminder as to what it is we do. When we're dividing these complex numbers, we do not care about the actual division itself. It's all about making sure that this number on the bottom is no longer a complex number. So we're going to change it by multiplying it by something to get it to become a real number. Now, as we spoke about in the previous class, in order to change a complex number to a real number, we have to multiply it by its complex conjugate. Now, the complex conjugate is just the same complex number again, except for the sign for the imaginary part, and just the imaginary part is changing. So instead of 1 plus 2i, I'm multiplying it by 1 minus 2i. Okay, so whatever I do to the bottom, I must do to the top. So I also have to multiply the top by 1 minus 2i. And it'll always be like this. So you will always be multiplying above and below by the complex conjugate of the bottom number, the denominator. Okay, so we're going to multiply this across, and I'll see if I get 4 times 1, I'll get 4. 4 times minus 2i is minus 8i. And now I'll multiply the 3i in. 3i times 1 is 3i. And 3i times minus 2i is minus 6i squared. So I'm going to leave it like that for the moment, and I'm going to work out the bottom. 1 times 1 is 1. 1 times minus 2i is minus 2i. 2i times 1 is plus 2i. And finally, 2i times minus 2i is minus 4i squared. Okay, so that's the two parts of the fraction multiplied out, and now we're just going to simplify it down. So if we're looking at the top, 4 is the only real number that's there, so I'm going to leave that as 4. There's nothing for it to go with. Whereas I got minus 8i plus 3i, and that's going to give me minus 5i. And then I got minus 6i squared. Minus 6 goes down as minus 6, but remember, anytime I see an I squared, you're changing that I squared to be a minus 1. And now we're going to do the bottom. 1 has nothing else to go with, so it's going to stay as 1. Minus 2i plus 2i gives me 0. In other words, it's disappearing, which is fantastic news because that's what we want. We want the imaginary numbers to go away, and that'll always happen with these ones. So those two numbers just disappear. So I'm left with minus 4i squared. Minus 4, and we know that I squared changes to minus 1. Okay, so we'll continue to simplify above and below. 4 minus 5i still have nothing to go with, but minus 6 times minus 1 changes it to a plus 6. All over 1 minus 4 times minus 1 becomes a plus 4. And now we can simplify it down. 4 plus 6 is 10. So I've got 10 minus 5i on top, and on the bottom 1 plus 4 is 5. And you can see I've pretty much achieved what it is I set out to do. I wanted to make sure that this number on the bottom was a real number. Now, it's really important. We always want our complex numbers to be presented with the real part separate to the imaginary part. So I'm actually going to continue this on to write it out as, instead of 10 minus 5i over 5, I'm going to write it out as separate fractions. So it'll be 10 over 5 minus 5i over 5. And if I can simplify those fractions, I will. So we can see then that if I was to put this into my calculator, it'll do it for me. But 10 divided by 5 is actually 2. And minus 5i divided by 5, well, 5 divided by 5 is 1. So that's going to remain as being minus I. And that's my question finished.